Alright, this is 11-1, day 1. Very beginning of chapter 11, we're looking at polar coordinates and complex numbers. We'll start today with looking at polar coordinates. Best way to think about them, like in terms of a big picture, is it's another way of describing a location on a coordinate. I don't want to say grid, because it's kind of the best starting point we have is using x and y. The horizontal component and the vertical component to describe a point's location on a two-dimensional grid. It's kind of what we're doing, except we use r and theta, okay, to describe the location instead of x and y. Okay, so let's say we had a point right here. All right, I don't know what we don't have a scale because we don't have the coordinate grid on there. Obviously, we have a polar coordinate grid. But certainly you could describe that point's location with the x component and the y, right? And this would be the x, that would be the y. All right, but without even moving at all and staying in the same location, okay, the length of that side, which looks to be 4, and the angle it makes with the initial side, which actually appears to be 45 degrees, would describe the exact same point in the exact same location. Okay? So instead of using, the x and y coordinates, we could say 4, 45 degrees. All right, describing that location in terms of the length of the terminal ray, and theta, the angle it forms with the initial side. That's what polar coordinates are all about. Again, on the big picture level, that's what they do. That's what they're for. So let's say we wanted to plot these. Okay. Got to get comfortable with this polar coordinate grid. Looks a little bit different. Looks like a dartboard is what most think the first time they see it. All right, 45 degrees and 3. Okay, remember this is saying that the length of that terminal side is going to be 3 units. That's going to be r. And the angle it forms with the initial side, which looks to be right here. That looks to be 45 degrees. So I go out 1, 2, 3 units. Okay, and I could mark on there that r is 3. And this angle right here with the initial side is 45 degrees. But you can see those two numbers are enough to describe a point's location. Okay, think about it if you were like starting at the center point and you're facing directly to the right. Okay, the angle tells you how many degrees to turn counterclockwise. And then r tells you how far to walk. Okay? Which again is gonna be enough information to give you a new specific location. Turn 45 degrees to your left or counterclockwise and then walk 3 units. If you were to do that, that would put you right there. Okay? Now, does this still have an x and a y component? Yeah, you could still describe that point with regular rectangular coordinates instead. Here's another one, -2 and pi over 3. Okay, pi over 3 is like 60 degrees, all right? So just think about it this way, that if I were to turn 60 degrees and then go 2 units, that would put me like right there. Okay, except this says -2. Okay, so I kind of turn and face 60 degrees, but then go the opposite direction. Okay, the negative would just mean go backwards instead of forwards. Okay, let's get that off there. But start with this though, because I think that makes more sense to think about that angle. pi over 3, which would be like 60 degrees, all right? I think it's worth just comparing here to help this make sense. If it was 2 and pi over 3, then it would be right here. That would be pi over 3. That would be 2, which looks more like the first one that we did. Okay, here it's the same angle, but now just go backwards 2 units instead of forwards. Try another one here. Okay, 20 degrees and 2 units would be, I think it makes the most sense to start with that. It would be something like that. Again, that would be if r was positive 2. Here it's negative 2. So go backwards. Okay, well, we don't need this part right here. This would mean that this reference angle is still 20 degrees right there. That says to come up with some others that would describe the same location. And there's going to be more points here that are going to describe this spot. Again, this is with theta equal to 20 degrees. So we'd start from right here, shift 20 degrees counterclockwise, and then r is negative 2, so we go backwards 2 units. Okay. One other point that would describe the same location is if I wanted to switch this to a positive 2, I could say just turn counterclockwise 200 degrees. Okay, that would be like that. You're 180 and then plus 20 more. That would be 200 degrees and r equals 2. Okay. See if you can come up with another one. Don't forget about coterminals. If we're in degrees, if you add or subtract 360, you'll end up in the exact, at the exact same angle. Keep that in mind to see if you can come up with another pair that's going to describe this exact same location right there. Same thing going on here. All right. Pi over 6 is like 30 degrees, so we'd go, I'm just estimating here because I'm just sketching these points. And it'd be something like that. There would be the point 3 pi over 6. If we wanted to think of another point, okay, that would be in that exact same location, okay, I could do, again, coterminal. I could add 2 pi. Whoops. Add 2 pi, not just pi, which would be 12 pi over 6, which would be 13 pi over 6. Okay. So that would mean just go all the way around and then come back to that spot. Okay. If I went out to 7 pi over 6, if I added pi, that would mean go out to here. And again, this is all in reference to this initial side right here. I could do the same thing we did on the others and say turn all the way to 7 pi over 6 and then go backwards 3 units. That would get me to the exact same point. Okay? So again, the big idea here is there's lots of different ways to describe the same location. Now let's talk about conversions really quick. If we wanted to go rectangular to polar, it'd start with r and theta. Well, we could find theta first, but if we want to start with r, just base it off of our x-coordinate and our y-coordinate. All right, really these are kind of two things going on here. I'm going to try to show you on the graph here what's happening, because these should remind you of just a trig equation with tangent, and the other one kind of looks like the Pythagorean theorem. If I just happen to say, and I'm not using the scale factor here at all, let's say x is 3, y is 4. So let's say it's describing that spot. Okay. To get theta, all right, think about this, this right triangle here. And one way in rectangular coordinates is to describe that location with the 2 legs of the right triangle, which is certainly sufficient to do it. And The other way is to describe it in terms of that angle and the length of the hypotenuse, if you will, which we're calling r. Okay? Now this is in the first quadrant, so I know that this should be positive. But if I did 3 squared plus 4 squared, that would give me r. And notice how this 4 over 3 is kind of like more or less the opposite over the adjacent, which is like a tangent ratio. So I could solve tangent of theta equals 4/3. I'll start with r. It's the square root of 9 plus 16. Looks to be one of those nice 3, 4, 5s right triangles where r is 5. Okay. Now I got to get theta, which I would just use my calculator for because I do not believe I'm dealing with an angle on the unit circle. Not terrible to find it. I just need to go to my calculator and do inverse tangent of 4/3. And we get 53.1 degrees. Okay? Now to write that formally as a polar coordinate, it would be 5, 53.1 degrees. Okay? Those 2 points are describing the same location, just in a different way. Okay? The first one is in terms of x and y. The second one is in terms of r and theta. Okay, if x is 3 and y is 4, the point that you end up, it means that r must be 5, and theta, which is formed by those 3 sides, has to be 53.1 degrees. Last thing here, I'll leave you to take a closer look at this. Just doing the exact opposite. Okay. We'll take a closer look in class as to why this is the case, but all you're doing here is if you're in r and theta to start, you can fairly easily convert to x and y. These would be numbers right here, r and theta, that you had to begin with. All right. So for x, this is saying r is 3, cosine is 30. You simplify that, you've got your x coordinate. Here, r is 3, y goes with sine. And you'd simplify those. Okay? Try this one on your own as well. R is 1, theta is 40 degrees, and you would follow those rules. Okay? We'll call it quits there. We're just hitting the highlights here of the discussions that we'll have on polar coordinates. But again, the big idea here, r and theta instead of x and y, an alternative way to describe points on a coordinate grid.